Okay, so the high-level roadmap for Patina, in case people are not aware, is if you go to the main page and you scroll down, you'll see what we plan at a high level. We have to plan at a high level because, like any project, things are subject to change as we move along, whether it's shifting priorities in terms of what we're implementing, the people working on the project, et cetera. But these are the three main kind of pillars that we're focused on. And if you go down into status, you'll see that component growth is one of those items. We have a few components that are in that place. For example, the SMBIOS component is one that we've integrated on the QEMU platforms that are open source recently and is available for integration on platforms. Also, we have an ACPI component, and Kat, who is in the call, has been working on a Patina boot component as well, which kind of serves a similar role to BDS. So that covers the kind of component growth portion. The other big piece of what we have planned is to do an core, and that's what I'm talking about now. So we're kind of going into that aspect of the high level roadmap. And that core, I put a link here to the RFC for that. So if you just click this Patina standalone supervisor, that will take you to the RFC. This RFC has been merged already. It was open for probably a month or two, but we can always amend RFCs. So if you haven't read through this RFC yet and you're just trying to get an idea of what we have planned for the core, in particular, what we talk about whenever we say supervisor, the RFC would be a really great place to start to get that information. So that's one place to go look there. Does anyone, I guess, have any questions about the RFC, if you've read anything about it or just any general questions about what we're planning there?
Uh, I read a bit about this RFC and I was wondering, looks like this one is focused on x64. Is that correct?
That is correct, yes.
Okay.
Right now, that's where the focus is. And so just to kind of clarify, like the work here, there's two large pieces to the work in terms of the firmware development. One is the core itself, which is primarily what we're providing with Patina. And then the second piece are the drivers that get executed by the core, of course. So we're working on this core piece here. We'll go through the hands in order. Oliver?
Yeah, just a comment on the ARM side. We have a very different model in mind, much more in line with what ARM themselves uses with secure partitions and not using standalone at all. We're still fleshing that out, but that's why you see this one focus on x86, right? They are, in the end, very different environments.
Yeah, my comment was very similar, which was like a supervisor and the core functionality is not even necessary on an ARM platform, given that the architectural differences in that in the secure world. So that's why this is very x86 focused.
All right. On?
So if that's the case, then what is the API that core is supposed to provide? Is that the equivalent to the runtime services or the GMMST that currently EK2 provides, or is it something more than that?
Are you talking about for the current proposal for the supervisor and core, or are you talking about for ARM in this case?
For the current one, for the current supervisor.
This is still converging to the communicate protocol as far as I'm aware. So it's should be compliant with either implementation.
Okay.
Yeah, the goal behind this is to provide the core environment. So it'll provide like the SMM services and things like that, and you'll be able to run standalone MM drivers that are compatible with the PI spec definition of standalone MM for the most part. There is kind of like in the standalone MM space right now, some slight differences in interpretation and just design choices that people have made. So there are some like small requirements that you'll need to pay attention to in terms of the way that you write your standalone MM drivers. And that's true of any time you're using a core environment. Sometimes, for example, they'll allow you to do things that other core environments won't. And we've tried to call those out in here. So, but for the most part, the idea here is this provides the core to be able to launch standalone MM drivers, and those drivers can be written in either C, or we want to provide the path here to be able to write them in Rust, of course, as well.
Okay. And then the other question I have is I'm not familiar with the supervisor MM. I tried to skim through the PI spec. They mentioned about it's sporadic according to PI spec that this writer MM. It say it can start in SEC phase, PI phase, Dixie phase, and seems like the one that you are doing is start at PI phase, right? The one that you initialize MM. Can you explain a little more? I don't know if this is the right forum, but can you explain more about the MM supervisor and MM user mode? What's the
Uh,
difference?
Sure, I can start, and if others on the call would like to add more, of course, feel free. Um, the idea behind the supervisor itself is to split execution in the MM environment between a privilege level, which is kernel mode, and user mode, right? Just like a normal supervisor. This allows us to be able to move the critical services that support the MM core into the kernel mode, and then we can have the MM drivers themselves. These are the things that like a platform would provide, right? That are dispatched by the core. Those would run in user mode. Now, what happens then is that these MM drivers need to do things that they do today that require privileged capabilities, whether it's writing to like IO ports or accessing MSRs and things like that. And so what the supervisor also allows is for us to be able to specify the access permissions for those operations. So we can specify things like what IO ports are allowed to be accessed, what MSRs are allowed to be accessed, and things like that. It also goes through like a syscall mechanism to be able to go back into the supervisor code and perform those operations. So you'll see some of that described in the RFC. That's a very high level view, Sean.
I think I was going to add, so, about 7-8 years ago, right, there was Secure Core PC was defined. Windows kind of defined a use case on x86 hardware for DRTM, and as part of that, the SMM environment had to be, controlled a little bit more. And so Windows worked with both x86 silicon vendors to kind of describe those requirements, and those vendors came back with, different solutions, but with very similar properties around the mitigations that were necessary. So this, and then as part of that, we also created an open source version of this using standalone MM that followed the similar protection levels with a slightly different mechanism. And the goal, so you won't find this in the PI spec, but the goal is to stay mostly compatible with the PI spec, but provide policy-driven, protections and kind of control the SMI execution so that SMI can no longer be used as an attack vector against a hypervisor and an OS.
Yeah, just one short additional statement there. Yeah, this is because, right, SMM lives through the OS, and that's why there are hundreds or thousands of CVEs about attacking SMM, because before supervisor and standalone MM, there were no protections, and so that had to be really tightened down.
Hopefully that's clear on, this doesn't really focus on the motivation aspect of this, right? There's whether it's a business motivation in order to meet something like secure core PC requirements, whether it is the attack vectors through like what's called SMM callouts is what they're called if you go look through the CVE database. That aspect is not really called out here because this is like more of a technical description of the design and solution. But if you want to get more information about those, we do have some resources available that we can point you to. We
Yes,
have
that will
actually
be great.
we have enumerated the actual attacks and the past problems in detail. So we do have some like data we can share there.
Yeah, that'd be great. You can point me to that. In my mind, in the old way, SMM has you can access anything from SMM, but now sounds like this one is moving closer to the ARM architecture where hardware is really controlled in SMM. You cannot access everything unless you're allowed by the supervisor. So I would like to read more about that, see where it's going.
All right, sounds good.
Thank you.
Let me see here. There is a so as people know, we work on Project Mu as well. The supervisor that Sean mentioned, the open source one that was written prior to this is in Project Mu, and a lot of the documentation that kind of covers the motivation and things like that is over there. So I'm just going to put a link to that. It's a all public documents. If you could take a look through that and then let us know if you have any more questions, you can feel free to also just reach out on the GitHub discussions page or whatever if you want to get a hold of us quickly. All right. Does anyone else have any questions about the MM work and what we're doing there? All right. If not, I'll go to the next topic, which is AI policy and code reviewer update. We've received a lot of feedback that people have found AI to be useful in their workflows, and we're trying to accommodate that. And as we go through these updates, I'll share like our policy around AI and then also some of the work we're doing based on direct feedback we've received. So the first thing is the AI policy. This was added to our contributing.md file. It's pretty straightforward. The things that we're asking is that you, if you do use AI in the development of code to Patina, that you kind of just follow our normal guidelines. Of course, like having AI generate the code. Some people are like, oh, this is ready to go. I can just push it up in a PR. And this is saying, make sure you just have the legal right to submit the code. People have to attest to that whenever they submit it. Make sure you fully understand the changes. If people have questions, just be prepared to be able to answer those questions. And sometimes AI can like generate code you don't understand at first, but if you go do some research and you kind of look at what it produced, you can figure out, okay, this is a solution. Maybe there's these alternate solutions, and now I, have rationale for why this direction may or may not be the best direction to take here. So you may not fully understand the changes at first, but just do some research there if you don't, is what we're asking. Next is to just thoroughly review the code. So this should be obvious. If the AI generates code, it might not be right the first time. In our experience, I think most people would probably say it's not right the first time, and you may need to iterate through it. And you can iterate through it through kind of a agent workflow with the AI where you're having the AI refine the code to meet your requirements, or you may need to go through it manually, right? But just go through that process is what we're asking. Make sure that you fully have reviewed and understand the code before it gets to others. And then testing, of course. So if you generate the code, just like how we ask for any code change, test those on QEMU. And we really prefer if you're able to test them on a physical platform. It's also understandable that people may not have a physical platform readily available that has Patina integrated. So if you don't, you can just let us know in the PR too. Just be like, hey, I tested this on QEMU, but I don't have a physical platform to test with. One of the Patina maintainers can take a look at your changes and we can figure out what a good testing strategy would be for your code. So just let us know if you don't have that. Any questions about the AI policy? Okay. The other ask that was made was to support a review workflow. So whenever we go into like what AI is capable of, there are a lot of different things. It can help explain stuff to you. It can review your code. It can generate code. What we are focusing on to begin with is kind of the more read-only aspect of this to help AI empower a developer, but not necessarily generate all of the code. And so that's what this first set of changes are for. So this was called the AI review skill. It ended up not really being a skill in terms of the PR that I've posted. It's a set of files. But the main idea here is to help AI understand the project specifics. We found that certain models, of course, are better than others at working with the code base. But the common denominator is that every model benefits by having a set of instructions that precisely points them in the right direction. And that's what this task was meant to add. So there's a PR that I have posted in the repository that's definitely open to feedback and even collaboration. People can feel free to either push to this PR or suggest any changes you'd like. But this is the pull request that adds this initial set of support. And it adds 4 main files. The first file is a set of always on instructions. These are in the .github folder. These are always run. So this is like kind of our core general overarching set of instructions that really any operation that you're doing with AI, we want AI to be aware of this information. So I'll bring that up over here and show what's in that file. This is what that file looks like here. And these are all in Markdown. So what this file does is the goal is not to duplicate information that we already have in our docs. It's to make the key information readily available to the AI agent so that it can operate on that information to quickly tackle whatever task it's doing. So you will see some level of duplication here with some documents, but the emphasis is on really the key pieces of information and then pointing it to existing documentation where it needs to go get more details. So the first one is the component structure. It kind of lets the agent know how we've laid out the code base and why we've laid it out that way. That way, if someone is adding a set of files, it can determine are those files added in the correct location or not. For example, is something in components that maybe better belongs in the SDK. So that's kind of what this is for. The next one is to quickly point to our key build commands. And at the end, it will point to makefile.toml because that is where all the tasks are defined. And it's a relatively small file that can be parsed pretty quickly. But these are the things that really need to be run, right? So it kind of informs it of that from a project standpoint. It also goes through some of our organization principles. If you go through code reviews, there are like a few things that come up often and they're somewhat opinionated. Like there's like any programming language, you can write code that works in different ways and you can organize the project in different ways. We've come up with some ways that we organize the Patina project, and this just helps call that out if you're not following some of those conventions. For example, we tend to avoid using mod.rs files. We like to use named module files in like a directory oriented hierarchy. there's some other things that we've come up with here that are listed. And so this just, if these happen, these will be reliable ways that you can kind of get ahead of someone having to tell you in a code review that you need to make adjustments. You can get that feedback locally through this. From a safety standpoint, the project also has been either established or been trending in certain directions with the ways that we handle unsafe code. And some of those like key aspects are covered here. The first one is you'll see some issues in the code base related to this, but we really prefer zero copy for a lot of memory layout and manipulation as opposed to using manual pointers and slice operations. So this is informing the AI that if there's an opportunity to use zero copy to improve an operation that's happening, let's go ahead and go that path as opposed to trying to do it through like raw slices or whatever. We of course try to minimize unsafe code, have safe abstraction wrappers, and document unsafe code and so on. So that's all covered in the safety section. In error handling, we also have some just key points there. We typically prefer result return types. We do not use, with very rare exception, panics in production code. We have certain ways we treat UEFI, ABI boundaries and things like that. One of the unique aspects of Patina is our component model. So this goes through the component model with some of the main information that's needed to be able to just see if the component model is being used correctly. It points to further documentation. So like, for example, if you are writing a component, the AI may go look at these documents, but if you're not, it might skip them. So that's why just the key information's there and then the references. Building and testing, one of the things that people run into often is they'll write code and then they'll get to a PR and we require that the code coverage on the patch be higher than 80%. And this is trying to get ahead of that so you can have that information ahead of time. So like if the AI sees that you wrote all this code, but you don't really have sufficient unit testing, maybe it's time to focus on test before we go to PR, right? And so you can get that out of the way before going into the actual PR phase of your contribution and so on. I won't go through all of them, but they're kind of similar. These are not meant to be comprehensive. It points to, like I said, existing documentation. So if you're not an AI agent and you're a human trying to understand how the project works, you should probably go look at these markdown files. This is really just to kind of orient AI in the right direction with the minimal set. That's what this is for. So again, this is, from my perspective, a starting document. I just wanted to kick it off with some things that I had in mind. But if anyone that works in the project is, pretty closely has any ideas as well, you can feel free to modify this file as you like, and you can even delete some of my stuff. I just want this to really be as effective as possible for the project. Sean?
Yeah, I was just going to kind of lay out, and maybe we need to have this in one of our other documentation files, but like, this stuff is changing so much that we don't want a ton of stuff added to the repository. I think even across our teams here, like everyone uses it slightly differently, and I expect that next week the answer will be different again. So we're trying to be pretty careful here, but we do want to add some things. We do want to, support the powerful tool of using AI for this stuff. So that's kind of the main goal of getting this PR up and, getting some of that kind of conversation started.
All right. I'll just quickly cover the other files. I'm not trying to do a full review of my PR, but I just want to hear. So the other file here is a prompt file, and it goes under the reviewer, right? And so this is a prompt file is a reliable way to instruct the AI on the steps it needs to perform. And so this is a prompt to review the code. That's what that file's purpose is. The other thing that you can do is have instructions that are specific to a given set of files. So right here, you see this apply to field. So this is saying one of the things that we have in Patina is a components directory, and we put most or all of our components underneath that components directory. So what this is telling it is like, if you're working with components, let's go into a little bit more detailed information about components. It's still not too much, right? We're less than 100 lines. But let's just dive a little bit deeper into some of the ways that we think about dependency injection and writing components. And that's what this instructions file's for. And we can also use this to our advantage if we have other instructions we'd want to apply to other file patterns. We can do that here as well. This one, the only one I thought that was very meaningful to start with was components. So that's why this one's here. And then finally, a very small file. This defines the reviewer agent itself. So if I go into my like chat prompt in VS Code or a similar UI, and I type in like /review, this will come up as an available agent to be able to review the code. And this will kind of instruct that agent on specifically how to review the Patina code, and in particular to use the Copilot instructions that I showed earlier. And it will find the other files as well because they're in standard placement that these tools look for. So that's the starting. So what we end up with, if we look at it all, is we have a always on instruction. We have file-based instructions for components. We have a prompt file for prompting the AI, and we have the reviewer agent itself. And then all of these concepts, I put links to where they're explained. So if you want to like take a look at, well, what's really the difference between a prompt and an agent, right? You can go look at these documentation links here, and it'll explain what these different files are for. All right, so that's the AI stuff. Are there any questions about that? Or any feedback? Okay, and we'll continue evolving as we see. Like Sean said, tools are changing often. The project will need to adapt as we start to see different capabilities and flows be enabled and things like that. But this is kind of a starting point to see how it goes. Okay, so that covered the AI stuff. Final one is just PR validation in Patina and Patina Dixie Core. This is a workflow that you'll see if you post a PR in the project. And I'll just go to my last PR that I opened. You'll see this be posted on the pull request. This is a workflow that will actually test your Patina code on QEMU. So whenever I said like it's great to test or it's basically a requirement to test your code on QEMU before it gets contributed to Patina, this actually enforces that. So whenever you make a pull request into the project, we'll take your Rust changes. We will compile them into a Dixie Core EFI binary, move that into a QEMU ROM file, and then we will run QEMU with that ROM file just to make sure we're able to reach EFI shell. We also have some tests that we run that are called Patina on system test, and those tests will run as part of this boot as well. So we can check for regressions and things like that that may be a part of your workflow. There are links here. So if you do post something and you see it fail, you can always click one of these links and see what you were running against. So it might be that there's a change, like in Patina Dixie Core QEMU, that your code doesn't work with. It's like not compatible with. And so you can just click this link, and it'll take you right to the commit in Patina Dixie Core QEMU that your code is being tested against, and so on for each of the dependencies. This happens here, and it also happens in the Dixie Core QEMU repository where we build the Dixie Core binary for the QEMU platform. So if you go to the pull request here, you'll see something similar as well. Let me go to one that went in recently like this, right there. Any questions about that workflow or what's happening there or anything like that? Okay. Continuing on down the agenda, we went through the supervisor. One of the other major work items that we have in progress at the moment is our EFI version 6.0.0 integration. This is a link to the release tag for this project. Our EFI is a crate, as it says here, with UEFI specification, constants, and definitions. We wrap ourselves around the REFI crate for a lot of UEFI specification definitions. And the reason why this works fairly well for Patina is that the REFI crate is pretty bare bones. It doesn't make a lot of opinionated choices about the way that it implements its Rust code. It kind of leaves that open to the code that wraps around it, which in our case is Patina. One of the things that it's kind of been a long-standing item with REFI is that it has a lot of these FFI functions defined for UEFI functions in the spec, but they were not marked unsafe. And what that meant is that whenever a project like Patina is using those functions, we're not having to make those calls in unsafe blocks. And in particular, we're not getting some of the visibility that the unsafe keyword makes available to us so that we can see we're calling something, we're making a call here that's to something that's unsafe, right? We need to check our variants before we make this call out to the C code. So the project updated all of their function prototypes to be unsafe function. Now, what this means is that we have a lot of work on our side to take this change. So they released it as a major version, right? It's version 6.0.0. So we haven't picked it up yet because we're on the 5.0 major version. But one of the items that we have, and I linked to here, is we have this work to go integrate our EFI 6.0.0. And that's broken up into a number of subtasks. And Vanil from the team is going to largely be leading this work. And so if you're interested in helping or anything like that, or where it's at, feel free to respond to this issue, but also reach out to Vanil if you're interested in maybe helping with some developer work there, because I think there's going to be a lot to do. And we also have to think as we go through this, it's not really just the mechanics of, okay, something's unsafe, I just need to wrap unsafe and call it now. We're kind of thinking about, we go back to safe abstractions, right? And so now if we have all of this stuff that's newly marked unsafe, it's probably time to step back and think, how do we write safe abstractions around these calls? Maybe before we just didn't think about it, or it wasn't a super high priority, but this presents the opportunity to be able to reassess, is there a better way that we want to make these calls or abstract these calls? And part of that is tracked in this task here. So I put this under related. This task is acknowledging the fact that we call our EFI directly in a lot of places, but maybe it makes sense to have an intermediate layer for Patina, right? To have one layer, safely wrap our EFI, expose a really clean, safe interface to the rest of the project, and then let's update all the other Patina code to use that abstraction. That's what this task is tracking. So it's kind of related to the work of the 6.0 integration. Are there any questions about 6.0 integration, unsafe functions, or UEFI spec compatibility, or anything in that area? Yes, son.
Can you give me an example of how you're gonna wrap around the REFI? The reason I'm asking is if we are not building within Patina and we're building in our code base ourselves, how we're gonna use that one, the one that you wrap around? Are you gonna make it public for the code compile build outside of Patina to use it?
Yeah, I've talked quite a bit. Does anyone else want to take this, or have ideas, or I can also keep going? I just want to give other people in Patina an opportunity to give a suggestion here about wrapping it.
If I understand it correctly, the question, so the intention here is basically to make sure currently within Patina, we are using REFI, I mean, the definitions, and we want to essentially this effort will tighten up the places where we really need to mark them as unsafe, and also places where we can create safe abstractions. Now, your question is more around being able to access them outside of Patina, because this would, as of now, is focusing on within Patina, like uh, 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 clean up places where we need to be more precise on the definition of unsafe in places where we are using it today. Um, can you explain your question a little bit more, like when you say the usage as such?
Yeah, we want to take advantage of the unsafe, the safe interface that you're gonna wrap around the unsafe in REFI.
But but my assumption is like you would be using Patina exposed APIs, right? You won't be directly dealing with the REFI definitions by yourselves, right?
Well, right now I'm using both, sort of both, REFI and Patina. So if you guys saying that, you know, you're gonna provide a wrapper for all of the REFI definition, then I need to redirect the code, change the code to point to Patina. But I just want to make sure, clarify, is that the intent of the task here? Is you
Right now,
be
yeah, right now I believe the scope of this task is to um, wrap around the usage of REFI definitions within Patina. I'm not really sure, like if external uh, projects directly use REFI. Yeah, I'm not sure about that.
I think it might be a little bit more nuanced. I think there's cases where the REFI definitions are perfectly fine as they are because they're just some simple definition. But there's a lot of places where wrapping adds value. I mean, a particular use case for this is for a lot of our type definitions, especially when you're talking about things like memory types or whatever. Um, the REFI approach is to basically define the C values, right? And the C values are fine in terms of C interfaces, but we lose a lot of the benefit that Rust provides in terms of things like enum. So if we in our Patina interfaces decide to instead use an enum for the memory types, that gives us a lot of benefit because we don't have to constantly be checking for valid types and all these other things because the compiler will enforce that for us. So the intention here is because we are going to really use an amalgamation of more Rust defined types as well as the actual C compliant spec definitions. I think that there's two parts here. One is we want to expose the SDK expose our EFI from within our SDK, as well as expose the wrappers which might be used within our interfaces. So in all such cases that we've done this so far, those things are interoperable, right? So you can have, like, we define intos for our new type from the REFI type. So that way you can easily convert between the two at the interface layer if that's what you want. Does that, I guess, better explain, or maybe someone correct me if I'm wrong there? But I think the point is that this is not a wholesale replacement and saying that, hey, don't use REFI. It's saying that for our interfaces that we're defining for services in our component model, for example, we're going to use a more Rust-like version of this, which can be converted easily from the C compliant version.
Yeah, I just wanted to add on like an example of that. So as Chris mentioned, and Vanil, there's going to be some constants. Whenever I said the REFI contains constants and definitions, some constants will make sense to keep, right? There's no need to redefine them if they serve their use case. This is an example of a place where this is just one that I'm personally aware of, where we took something from our EFI and wrapped it with a type in Patina in order to improve developer ergonomics and make the code overall cleaner, but maintaining binary compatibility. So GUIDs are somewhat complicated, and our EFI has its definition of a GUID from the UEFI specification. Now, the problem that we get into whenever we use the REFI definition of a GUID type, which as you can see on the left is here, defining a protocol GUID, it's not very friendly, right? This one is defining this as fields, but we typically think of them like this over on the right. And that allows us to be able to search and search for these GUID strings that are matching the C code and also matching probably a specification or something else, right? And so while this new GUID type also allows you to specify things by fields, it gives you the ability to also have a const string for the GUID value. And so this is an example of an ergonomic improvement made in a GUID type defined by Patina. In addition, this binary GUID is a transparent wrapper around the REFI GUID, so it's completely binary compatible. It just adds these extra bits of functionality on top. One of the other key pieces about what we've done with the GUID type in Patina is make it also zero copy compatible. A lot of data structures have GUIDs in them, and one of the barriers to people using zero copy is, hey, I have a data structure with a GUID type. And whenever that's happened in the past, we've kind of had to, it's complicated the situation, right? Or we just don't use zero copy. So what we've been able to do is define a GUID type that does derive zero copy traits on it. And so it's zero copy compatible. And so there are cases like this where there will be reasons of why we abstract it, whether it's in order to improve our ability to have memory safety, like be more zero copy compatible. It improves developer ergonomics. Like our debug implementation on this GUID type is much better in terms of showing the GUID value and information than the default one. But whatever the case is, we will provide that wrapper around it, whether it's safety, ergonomics, et cetera. But you still might have some constants come from REFI. Does that make sense on? I think part of this will be like, as we work on the project together, we'll see what makes sense to move over to the wrappers in the SDK. And then you can pick those safer, more convenient wrappers up from the SDK as they become available in your code.
Yeah, thanks for explaining this very well.
Okay, so that's all the REFI integration stuff. So that was mostly a heads up to people that we do work with the external crate, and we requested this change to be made, and we're going to be working on the integration of it. The next one is our UEFI services. This one here is basically, I put the old PR for this because I haven't posted a new one yet. But the main idea here is that whenever we write components today, we're directly depending on boot services and to some extent runtime services in order to access certain services that we need to use in our component. For example, whether or not we want to use the UEFI variable interface called locate protocol, locate handle, etc. And so what this task does is define an abstraction for those that is safe in Rust. So it's kind of related to what we were just talking about as well. Instead of directly calling functions off of the boot services table, we will have an abstraction that will provide a more idiomatic Rust interface for us to use. So that's called UEFI services. I will post a new version of this PR soon. That's something that I'm working on, but there's a lot of design decisions to be made there. That's another task that we have in progress. The other one is the Patina boot feature. This one, Kat is largely working on, and I think she can speak more to it. Before we get to that, we can take your question.
So Patina unified services, you said it will be a replacement for boot services, EDK2 boot services and EDK2 runtime services. Is that correct statement?
It won't be a complete replacement for them in the general sense. It'll be a alternate interface for them that is exclusively available to Patina components to use that will work better with the Patina component dependency injection model and provide more safe and ergonomic wrappers around the same set of functionality. So the other services will still be available to other code. This is what we'll recommend Patina components use instead.
And will it be the same set or will it be more like a superset of the one that's provided by the EDK2?
It will conceptually be an equivalent set. It'll be the same services with more idiomatic interface definitions.
Okay.
An example is like right now today, if you write a component and you want to use a boot service, you have to call, and I can go back to the PR here. Let me, I didn't put it up there. Okay. If you go to today, if you call a service, and this is a fairly large one, but you can see over here on the left, it breaks these services down more by their domain as opposed to just one boot services table. So today, if you write a component and you depend on a boot service, you have to depend on all boot services. Instead, in the future, if you are writing a component and you only depend on protocols, right, you can put that in your dependency injection and not have to depend on all these other things. You can be like, I just need protocol services. Or if you need image services, you can depend on that and not depend on everything else. So the idea is that it will be a complete refactor and redefinition of the services, but provide equivalent functionality to your component. Subject, of course, to the final design. I'm just showing here an example of how it's broken up at this time.
Thank you.
Yep. Kat, do you just want to maybe give a quick, like, few minute overview of what you're doing with Patina Boot and the goals of that work?
Yeah, sure. So right now, making this boot orchestration component. Basic overview is that at the implementation that I have working right now on the feature boot or feature Patina boot branch is I have a boot orchestrator trait. The difference between like BDS, Dixie, and this design is that you can have like a pluggable boot flow interface. I've also made like a builder. So this is how you configure your boot options. So we have a boot config. You can specify a primary boot device, a secondary one. You can also have hotkey detection and also a failure handler. I've implemented this with a very minimal boot manager. So I have an example component called Simple Boot Manager, which implements the full default orchestrator. So I have connect, dispatch, interleaving, and a Dixie. I have console discovery, some hotkey detection, and it can also do like ready to boots. It also does boot attempts too. Coming up on the RFC, I have some new things that I'm looking for feedback on. I'm going to implement a connect controller trait. So right now I'm using like connect all as the connect strategy, but to show that we can like customize our connect strategy, you can implement a connect strategy. So that is what I'm looking for feedback on, and that's what's coming up. On the other end of that service, or other than that service, I'm also implementing some more boot variables like boot next, platform recovery, some also the key variable driven hotkeys, those variables as well. Let's see. I think that should be it. Yeah. So mostly just from just like call to action from this community is take a look at the RFC to see if you have any feedback for Connect controller service. I think that's all.
All right, thanks. And maybe can you just give a little bit more info about the testing you did on QEMU and what you have working there?
Yeah. So basically what I have is if you take a look at the simple boot, let me check what the name was. Simple boot manager. Yes. That is what's implemented with like the full minimal boot flow. Not entirely UFI compliant yet, but basically I was able to get this working on Q35 and oh yeah, you're on my branch. Cool. Yeah. So this works on QEMU, Q35, and SPSA boots. I in the testing I used like just a shell path to go to boot x64 or the boot Arch 64 EFI. So that should work now. I don't think I didn't commit these yet on Patina Kimu, but I think I have the integration on Dixie Core Kimu.
Okay.
Yeah.
So I guess the point is people can find your end-to-end integration between all these different repos if they go to the
Exactly.
PR section. So
Yeah.
in Dixie or QMU, we have this one
I
here.
think, yeah. Yeah, exactly. Yeah, you should be able to at least see how it's integrated in, like that boot component, the manager, and how it uses the Patina boot components. Yep, so that works end to end as well.
All right, thank you. Finally, we took an issue to make Patina training videos. Those are something that a few of us have taken up. You can see that I have a video here for build-in integration. Oliver and the team is going to do some developer examples and walk through how to add some code to QMU, verify it works, and stuff like that. Chris will be covering debugger. We have pretty good debug support in Patina, the ability to be able to step through code. We can even like reload a Patina Dixie Core build in the middle of boot, so you can hot load new builds of Patina Dixie Core and stuff like that. And then finally, once all that AI code review stuff is finished, there'll be a video demonstrating how to use that in VS Code that we'll make available. These will be posted on the, as it says up here, on the Patina YouTube channel. We have an ODP channel, I guess, on YouTube. We'll post it there. Finally, there's been some support or interest in security work streams. So this is a plan from Jalen at Intel to take a look at crypto, some secure boot enhancements, and things like that within the Patina project. So this might be a work stream that we kick off in the near future if people are interested in this type of work. Okay, we're at time. So An, I see you have your hand raised. We'll do that and then we'll call it a day.
Quick question about debugging. I think debugger, the WinDBG works well with QEMU. Have you tried WinDBG on a hardware like x86 system?
I'll say quickly that we have, and a lot of us actually use that as our preferred method for testing Patina changes now.
On real hardware?
Yes.
Yeah, we've tested it. I mean, we've tested it to varied degrees depending on the hardware on both architectures on real platforms, and there's no known outstanding issues regarding that. I think on the x86 side in particular, yeah, it's become a pretty standard process, so it's getting some pretty good some test coverage. So there shouldn't be any issues there. I definitely encourage you to try it once you get Patina set up, and if there's any problems, let us know. But everything should work as expected. It should be roughly the same with some slight setup changes, but the experience should be more or less the same as QEMU.
Will it work without rustic C core?
Well, so I mean, it's built into the Rustic C core here, right? So we're talking about the software kernel based debugger, the one that operates through exception handlers. So the Patina debugger only will work with Patina because it's built into Patina. We do have a Mu debugger that works with the EDK2 core in our Mu feature debugger repo. That can be used with EDK2. It doesn't have to be used as part of Mu. You're welcome to take a look at that if you're using the traditional C Dixie core. But yeah, I mean, for the purposes of this, for the purposes of Patina, yeah, I mean, you need the Patina core.
And is there any particular hardware that we need to purchase, or?
No, I mean that's kind of the reason for this, right? Is this operates purely through software and the serial port. There's no hardware necessary. You don't have to buy anything. There's no licenses. It's all completely open and free.
So I will say like the reason why we find this really valuable for Patina development is we don't have to reflash, right? We can boot up, we stop right at a certain point in boot. We tell WinDBG which image we want to load, and then it loads it, and we say go, and we take off with our new Patina changes. So it really shaves a lot of time off of the developer flow of having to reflash and stuff like that. In addition to providing us debug capabilities.
Also, I just want to point out one thing. You mentioned WinDBG. I mean, so that's our preferred method, just because WinDBG. I mean, there's maybe some bias here, but WinDBG is a pretty good systems debugger. It has a lot of really good functionality for working on bare metal. But I mean, we do support LDB or GDB. It's just the tooling there we have not spent much time on. I mean, I would welcome people to spend time on it. It's just, we can only do so much on our end. So if WinDBG is not your preferred debugger, you can use any GDB remote protocol compliant debugger. We just use WinDBG, and that's where we've been investing our time in building tooling.
Thank you.
All right. There will be more details in the debugger video. So I guess that's a good preview of the information you'll get there whenever that's available. All right. Thanks for joining, everyone. I'll talk to you next month. Bye.
Thanks, everybody.
Thank you.